Hi folks, we're going to take a look at number 9 from the October 19th homework. So here we've got a logarithmic equation, okay, and it's one of these where we've got several logarithms that contain variables, okay. So remember that our main goal for solving these equations is to eventually have one single logarithm on one side of the equation equal to some number, so I can then change that into exponential form and hopefully get something I can solve, okay. So since I've got these different terms that are being added, and when I bring this to the other side subtracted, I'm going to want to use those logarithm laws. Okay. There is one little hitch that you need to be careful of here, is I've got this 2, which is in front of this log base 2 of x, and that does not fit with our logarithm rules because it's basically log of a plus log of b equals log of ab. Okay, or minus gives you division. Okay, it doesn't account for having any coefficients. But what we can do is we can use the third logarithm law, okay, the ski-slope rule, but going in the other direction. So write this as log base 2 of x squared. Okay, and then I'll get the correct scenario. So let's start here by bringing this coefficient of 2 into the exponent. Okay, so log base 2 of x squared. I'll bring that to the other side, so minus log base 2 of x minus 4. Okay, and I'll leave the constant on the other side. Okay, so what we need to do now is bring all of these under one logarithm, which I can do using the first and second logarithm laws. Okay, so this is going to be log base 2 of x minus 1 times x squared. Okay, and then divided by this x minus 4. Okay, and that's all equal to 1. And this is the scenario I was talking about, because now I've got a single logarithm equal to some constant, and now I can use the change of the alternate version, the exponential version of this equation. Okay, so what is that alternate version? Is it's base 2 exponent 1, so 2 is equal to the result x squared times x minus 1 over x minus 4. Okay, and what we have here now is a rational equation that I can solve. Okay, so let's go ahead and do that. So solving rational equations is about eliminating the denominator, so I'm going to multiply both sides by x minus 4. So on this side, x minus 4 disappears. Okay, and so here we've got 2 times x minus 4. Okay, so this gives us x cubed minus x squared, and this gives us 2x minus 8. And so here, cubic equation, bring everything to one side of the equation, x cubed minus x squared minus 2x plus 8 equals 0. Okay, and now let's take a look, quick look at grouping, and I notice here grouping does not work. Okay, so when grouping doesn't work, we have no choice but to try the factor theorem. So let me call this f so I can show my work. So here, let's start f at 1. Okay, so here 1 minus 1 is 0, minus 2, negative 2, plus 8, not equal to 0. Okay, again, I'm just looking at factors of 8 now. Okay, f at negative 1, so here this gives us negative 1 minus 1, so negative 2, plus 2, because subtracting 2 times negative 1, so 0 plus 8, not equal to 0. Okay, let's move on. F at 2. Okay, so here, let's take a look. We have 8 minus 4 is 4, minus 4 is 0, plus 8, not equal to 0. Okay, let's try f at minus 2. Okay, so this is going to be negative 8, okay, minus positive 4, so negative 8 minus 4 is negative 12, plus 4, okay, 2 times negative 2, so plus 4 brings me back to negative 8, plus 8 is 0. And so there we go. We have our first factor, which is going to be x plus 2. Okay, and now we have to find our second factor, and we do that by doing a division here. So I'll do this here. So we have our coefficients 1, negative 2, 8, and dividing by x plus 2, so we need to put a negative 2 there. So here, bring the 1 down. This becomes -2, -1 plus -2 is -3. So this becomes +6. -2 plus 6 is 4. And just to check for good measure, -2 times 4 is -8. So we get 0 as our remainder, as we need. So this means, okay, that our second factor is going to be x squared minus 3x plus 4. Okay, and of course this is still equal to 0. Okay, so here we have that x can be equal to -2. Okay, or, well, here I take a look at this, and with 4 and 1, they either have to both be positive or both be negative, so I can't get to -3. And with 2 and 2, again, there's no way I can get to 3, so we'll have to use the quadratic formula. Okay, so x is equal to -b, so 3 plus or minus square root of b squared, so -3 squared is 9, minus 4 times a, which is 1, times c, which is 4, over 2, and so that's 3 plus or minus square root of 9 minus 16. That's going to be a negative number. So there's no solutions that come from this second portion. Okay, so our only solution to come out of this cubic is -2. Okay, but given that this is a logarithmic equation, we know that logarithms have conditions on them. So if we go back to the original equation, and right away in that first term, I see that if I put -2 into here, -2 minus 1 is -3. I cannot take the logarithm of -3. So right off the bat, I have to also eliminate that solution. So in the end, well, we've run out of solutions, so no solution. Okay, so just to recap, okay, when you're solving a logarithmic equation, your goal is to use whatever algebra you have. So in this case here, we used all 3 logarithm rules to eventually write it as a single logarithm equal to a number. From there, convert it to exponential form, then solve the resulting equation, and lastly, be sure to always check that the answers you get, because here those are answers to this polynomial equation, or actually originally to this rational equation. Make sure that these answers do indeed satisfy the original equation, and if they don't, you got to get rid of them. Okay, that's it for this one.